Hello everyone, welcome back to another YouTube video. Today I am Nishita and we are also going to solve an interesting problem which is based on a linked list, and the problem is also asked in Google. Let's look into what the problem is all about. The name of the problem is remove nth node from the end of the list. Let's see what we need to do in this problem. So it says, given the head of a linked list, remove the nth node from the end of the list and return its head. Let's try to understand it with an example. So initially, we have been given with this linked list by the name head, and this is the list 1, 2, 3, 4, 5, and we have also given the value of n, which is 2. What does it says? It says we need to delete the nth node, means the number of node that we that is being given to us from the list, but from the end part, not from the first, from the end part. So let's see what is happening in this example. This is the list which is given to us, and it says n is equals to 2. So we need to delete the last second node from the linked list. Okay, we need to delete 4. And let me tell you, this is a singly linked list, so we can only traverse forward and we cannot go backwards. So it would be a challenge for us to delete the last second node from the linked list. So let's see, what will be our output? If we delete 4, our output will be 1, 2, 3, 5. Correct? In the next example, the head is 1. We only have one node in the list, and n says 1. Delete one node from the last. We only have one element, so it will be deleted and our output will be empty. Okay, an empty linked list. Next, it has two elements, 1 and 2, two nodes in the linked list, 1 and 2, and the value of n is 1. Which node would be deleted? The node from the last, right? 2 will be deleted and our answer would be 1. Okay. And these are the constraints. These are the very important part of the problem. Everyone should uh, pay attention to this part. So the number of nodes in the linked list is SZ. It has taken the number of nodes as SZ. And the maximum number of nodes we can have in our linked list is 30, and the minimum would be 1. So these are the number of nodes. The value of the nodes would be between 0 and 100, both included. And n, which is the number of node that we need to delete, would be lie between 1 and sz. Sz means the number of nodes we have. Okay, so it can be 1 in the as its minimum range, and it can be sz, which is the maximum number of nodes we can have, as its maximum range. So these are the constraints, and this is the example. I hope you understood what the problem is all about. Let's move on to the approach part now. Let's see what the approach we will be using. So now let's discuss the approach. Let's discuss the first approach that comes to my mind when I see this question. Here is my marker. Yes. So this is the linked list that is given to us, and n is equals to 2. As I already told you, the linked list is singly linked list. We can only traverse forward and not backwards, right? We cannot travel backwards. So how we are going to trace the last second element in this linked list? What we are going to do? We can check the size of the linked list, right? What's the size of the linked list? 1, 2, 3, 4, 5. The linked list has 5 nodes. I'm going to take 5 and I'm going to minus the value of n, which is 2. It equals 3. So it tells me the node that I need to delete, it will be on the 4th position from the starting of the linked list. Okay. If I'm gonna I'm gonna traverse this linked list by this number 3. So we can have 1, then we are gonna have 2, then we are gonna have 3. And 4th is the 4th element, right? That I need to delete. Means I need to delete the whatever the value I get. Suppose I say it value whatever the value I get, I need to delete the node which is value plus 1. I need to delete this node from the beginning of the linked list, right? Do you get it? Means whatever the value of n is given to us, I just need to calculate a value by minusing this value from the size of the linked list, and I'm going to delete that value plus 1 node from the linked list, and my solution is this, and I will get the desired output, right? We can use this. But what's the problem in this approach? I need to travel the linked list twice. This is not the most optimal approach, okay? I need to travel the linked list twice. That's why I'm going to tell you another approach which is more optimal and which is more efficient, the approach number 2. Okay, so what we are going to do in this approach, we are going to take 2 pointers. It is called 2 pointers approach. We are going to take 2 pointers, okay, and let's see how we are going to traverse the linked list. By using these 2 pointers, we are only traversing the linked list once. We are only going to traverse the linked list once, okay. So I have taken 2 pointers. The name of the first pointer is first, and the name of the second pointer is second. I have taken these 2 pointers, and I'm going to denote these pointers by F and S. F means the first pointer, S means the second pointer, okay. And I'm going to initialize these 2 pointers to the head of the linked list. Both are initialized to the head of the linked list, means initially both the pointers are here. F is also here and S is also here at 1. This is the linked list that I have taken 1, 2, 3, 4, 5. It is the same example, and N is 2 here. N equals 2. I need to delete the last second node. I have just written null here for the reference, because after 5 there is no other node. It means null is there. Okay, it is not included in the linked list. It is not given to us. I have just wrote it for your reference to make it easy for you to understand. Okay, because we are going to need this in the future. So let's see how the pointers will work. So initially both of my pointers here are here. The F is here and the S is here. What I'm going to do, I'm going to traverse this S till the node which is at n plus 1 position. You already know why I'm taking this n plus 1. N is 2 here in this case. I'm going to traverse our second pointer till n plus 1 position. Okay. So n is 2 till when my pointer is going to traverse till 3. No, not till 3, till 4. Because initially it is at 1. So it is going to traverse 3 times, right? Because n plus 1 is 3 in our case. So my S pointer will go 1, 2, 3 till 4. S will be here. Okay, right? Do you get it? Why I have taken n plus 1? I have already told you in the previous example. N plus 1 gives us the position, the correct position till which our pointer should get. Okay, so I'm gonna traverse till 4. When I reach here, when I reach at n plus 1 position, I'm gonna start my first pointer to move. I'm gonna make this first pointer move till I reach here. Till then, first pointer will not move. It will be here in the head position of the linked list. Okay. So my S pointer is here. When my S pointer reaches the n plus 1th node, I'm going to move my first pointer 1 time. Okay, I'm going to increase it by 1. So my F pointer will be here. After that, my S pointer will also move, and it will move till 5. Okay, so let me make it clear for you. Now my S pointer is here and my F pointer is here. Again, I'm going to move my pointers. Let me delete this for your clarity. Again, my S pointer was at 5. My S pointer is going to move again, and my F pointer will be here on 3. It is on 3. Okay. Now, my S pointer has reached null, means there are no other nodes to visit. Then what I'm going to do, I'm going to delete, and you can see my F pointer is on 3 and our next node is 4. 4 is the node that we need to delete, right? So what I'm going to do, I'm going to delete the node which is at F plus 1 position. I'm going to delete this node, and hence uh, uh, our problem is completed. Our problem is done. This is what we needed to do, right? We needed to delete the node which is at nth equals to 2 position from the back of the array, and we have deleted the node by only traversing the array, by only traversing the linked list once, not the array, it is the linked list, only traversing the linked list once. Okay, to make it more clear, let us do this example one more time. Okay. So initially, these are the 2 pointers that we have, first and second, and I'm gonna denote these pointers by F and S. Initially, our pointers will be at this position, the head of the linked list, F and S. Okay. Next, let's see what's the value of n. It is 2 in our case. Let's take it 3. To understand it easily, let's take n is equals to 3. So our n is 3. And what does it mean? It means we need to delete the last third number. Last third node means 5, 4, 3. We need to delete 3, right? So initially our both the pointers will be here in the head position. What I'm going to do, I'm going to move my second pointer, which is S, till the n plus 1 position. Okay, what's n plus 1 position? It will be 4, right? So my S pointer will move 4 times, not the 4 as value, but 4 times. So S, I'm going to move 1, 2, 3, 4. S will be here on 5. Okay, so my S is here. When the S reaches its n plus 1 position, I'm going to start moving my first pointer. Okay, and I will increase this first pointer by 1, and my S pointer will also increase. This is the initial condition, that initially we need to move our second pointer till n plus 1 position. Till then, first pointer will remain at head position, it will not move. When the S reaches its desired n plus 1th node, we are going to move both the pointers by 1. Okay, we are going to increase both the pointers by 1. So S is here, first pointer will move by 1, it will reach here 2. Then S will also increase by 1, right? And S will reach here, null, till null. S will say, now I have reached null. There is no other node that I can visit. When S reaches null, I'm going to check at what position my first pointer is at. My first pointer is at second node, right? I'm going to delete the next node of the first position. I'm going to delete first plus 1th node. And this is our desired node, right? This is our desired node, which is 3. So by using this approach, you can delete the desired node. Do you get it? I hope you get what I'm saying. Now let's move on to writing the code. And when we will write the code, I'm also going to explain you each and every line of the code. And also we are going to dry run the code so that you can get the idea how this is working. So let's write the code here. First of all, we are going to create a node. Okay. We are creating this node, list node temp. This is the name of the node temp. Okay, this is a temporary node, and initially it is 0, which means this node is in the beginning of the linked list. Initially the node is 0, which means this is the linked list 1, 2, 3, 4, 5. Where the node would be, it would be before 1, like this, 0. Here, we're creating a dummy node before 1. Okay, I'm going to tell you why we have created this a dummy node. Okay, next, we are going to initialize the node where the node would point to the head of the linked list. Okay, so it is going to point the head of the linked list, means the head of the linked list is 1. So the node that we have created would be before it, uh, like this, and it will point towards the head of the linked list. Initially, that was the head of the linked list. Okay, so this is the node that we have created, a dummy node, and we are going to initialize our 2 pointers. Okay, now let's see how we have initialized the pointers. These are our pointers by the name sec means second, and first is the first pointer. We have both initialized the pointers to temp. Why we have initialized the pointers to temp? Because as I have told you initially, our both the pointers will point towards the head of the linked list. Now we have new head of the linked list. We have created a dummy node here, right? Both the pointers will point to this dummy node head. Okay, this is the head of the linked list. Both the pointers will point to temp. Okay, then we are taking a for loop. Why we are taking a for loop? To iterate throughout the linked list. And what we are doing, till when we are iterating till the value n plus 1. I have already told you in the approach why we are traversing till n plus 1. We are traversing till, here n is 2, we are traversing till 3. Okay, so it will traverse till n plus 1, and what it will do, it will increase the second pointer, right? It will keep increasing second pointer till it reaches the n plus 1 position, right? It is pretty simple. We are following the approach step by step. After that, what it says, move both the pointers one by one till the second pointer reaches null. That's what we were doing, right? Till our second pointer, first we are increasing the second pointer till n plus 1, right? After that, when it reaches the n plus 1th node, we are gonna increase both the pointers by 1, right? We are gonna increase both the pointers one by 1. This is what it's doing. And in this while condition, it is written that till the second pointer reaches null, we need to increase both the pointers, right? Correct? Now, what happens when the second pointer reaches null? We need to delete the node which is at first plus 1 position, means the node which is the next node of the first pointer. Or if our first pointer is at 2, the next node of the first pointer should be deleted, right? This is what we were following in our approach. So, whenever our first pointer reaches, no, not the first pointer, whenever our second pointer reaches null, we need to delete the uh, node next to the first pointer, right? So this is how we are going to do. Why we haven't written any if or while condition? Because we already know if the second pointer reaches null, it will automatically come out of this loop, and we are going to delete first dot next, next. What we are doing here, right? See, here we need to delete the 4, and our first pointer will reach till 3, right? By our approach, our first pointer will reach 3. We need to delete 4. As in Java, we code in Java. Java doesn't have any function like delete in it. So what we are going to do, we are going to simply skip this pointer. We will make our 3, the pointer which is at 3, we will make it to point to 5, and we will skip this. So what we are doing, first dot next means this 4, it should be equal to first dot next, means we are at 3 and it should point to this. It means 4 is skipped, which means 4 is deleted. It is as similar to that. So we are skipping the node which we want to delete, and this line is doing that, right? After that, what we are going to do, we're going to simply return temp.next. Okay, this is our code. Now I'm going to tell you why we have created a new node. Why do we need a new node to place in first position of the linked list? The code is working fine without it, right? But there is one condition. If there is only one element, let's see the example number 2. If it has only one element in the linked list, if it has only one node, and we need to delete that particular node only, the code will not work, because we do not have any pointer which is pointing towards head initially. We do not have any pointer which is pointing to the head initially, right? So we need another node to point to the head of the linked list, the original head of the linked list. Okay, that's why we have created this dummy node, so that it can handle all the conditions. Now this particular code can handle all the conditions, and it will work fine with any example or any test case. Okay, let me check the code once. Yes, the code is correct. Now let's try to run the code. Let's check whether it's working fine or not. It is giving us correct answers, right? 1 2 3 5. It is deleting the node 4. Here it should give us empty array. It is giving us null because that's the last point it reaches. Nothing is there. And in the third example, it should delete 2 and should give us 1. It is giving that. Yes, 1, and then it reaches null. Null is there because I have written it here in this system.out.println line. I'm printing it to make you more understandable, to make it more understandable for you. So this is the code and this is the problem. I hope you understood the problem really well. And let's meet in a next video with another problem. Till then, take care. Bye.